Alright, good day class. You're welcome once again to my YouTube channel, Master Science Guide. Now in today's video lesson, we are going to be looking at the Iupac nomenclature, alright? The Iupac or systematic names, alright? So Iupac nomenclature of compounds. Now we are going to start with the most foundational compound we can begin our journey of Iupac nomenclature with, and that compound is the alkanes, alright? Now, to understand Iupac nomenclature, you must understand naming of alkanes. Only when you understand the alkanes, then you can progressively know other corresponding compounds in which you can use the Iupac system, like the alkenes, the alkynes, the ethers, the alkanoids, and so on and so forth, and all other compounds. All right, now there are certain Iupac rules you need to understand, and as we progress, more of these rules are going to be exposed. But then these are the four most foundational rules, right? Every other thing is just addition. When you're talking about bond, functional groups, how you name the functional groups, and all of those extra stuff. But then in order to understand naming improper, you have to understand naming of alkanes. When you understand naming of alkanes, every other compound being named becomes very, very easy. All right, now look at this. Look at the rules. Please take your time to pause this video. All right, write out these following rules, okay, so that we will now move on to examples. So just a quick run through so that you get a glimpse of what we are talking about. Now, there is no principal rule in Iupac nomenclature. There is no principal rule, but then I will tell you that there is a core or a main rule you must not miss. Now, that main rule is rule number one. Rule number one. And what is rule number one? It says the longest continuous carbon chain is chosen as the parent chain. So please, I want to state this, that if you miss this rule one, failure to identify the longest continuous carbon chain, you've already failed naming the compound. If you cannot properly identify the longest continuous chain, you have literally failed the compound. You cannot name it. So the first thing you need to do is that you need to properly and correctly identify the longest continuous carbon chain. Now that longest continuous carbon chain is now taken to be what? The parent chain. All right. Then rule two, number the parent chain. So that longest carbon, number it. All right. So it might be 3, might be 4, might be 5, 6, 7, 8, 9, 10, 14. Well, might get to 14, might not get to 14, but then please always make sure what you now number your word parent chain. Now the direction of numbering chosen is that which gives the lower number to the substituent. So when you have, what is a substituent? A substituent is an atom or group. Okay, let me just put this way. Substituents are groups that is not part of the parent chain. So any group not part of the parent chain is regarded as what? A substituent. Any group, please, you can write this down, any group not part of the parent chain is regarded as a substituent. Then 3, where there are more than one substituent of the same kind, the direction of naming must be that which give the lowest number to the first locant. So if you have, for example, you have a compound and there are, then we are going to look at practical questions to this. So probably you have a compound and you have substituents, all right, arranged at different points. Then your direction of numbering will start from the side where you have a closer substituent. So for example, if you look at a chain, for example, and you discover that if you start your numbering from here, from this side, your first substituent will be at this carbon. Then you now also observe that if you start your numbering from this side, your first substituent will be here. So from here, we have 1, 2, 3. Your first substituent is on carbon 3. From this side, your first substituent is on where? Carbon 2. Here is on carbon 3. So which direction of numbering will you now use? This side. You now start with 1 from here. So that is what this rule is trying to say. So, but then when they are of the same kind, you now use prefix like di, tri, tetra. All right. Then lastly, when two sets are equally possible, the order of prefix in the name of the substituent is arranged alphabetically. So when you now have probably let's say you have two different substituents. All right. You have mitai and then you have itaye. So you have itaye and then you have what? Mitaye. Now both of them, the numbering, yeah, if you start from here you get two, if you start from here you get two, so it's equally possible. So you now use alphabet. So which one comes first? Itai, e comes before what? M. Mitai. Itai, e, that's letter E. Letter E comes before what? Letter M. So since E comes before M, you just use alphabetical orders. All right. So now, please, I want you to write these things down. Then let's move to practical questions. Look at these two questions. Let's try to name them. All right. Now look at the first question. Now, what is the most principal rule? Like I told you, I said there is no official principal rule, but for me, there is something I like to call the main rule. All right, which is rule number one: identify your parent chain, and the parent chain is what? The longest continuous carbon. That is what is taken as what? The parent chain. So please don't forget it. So now identify the longest continuous carbon here. All right. So you have this CH3, CH, CH. So which one is long? Let's try to count. Now, before you even do any form of counting, please always learn to properly open the structure. This is where examiners love tricky students. All right, they can give you a decondensed structure and ask you to name that compound. Now before you name, all right, sorry, they'll give you a condensed question. All right, a question that is packed. Like these questions now, they are mostly, this is an open chain structure. All right, for this question is mostly open chain, but then in exam conditions they are going to condense the structure, right? And I'll show you examples of those condensed structures. All right, but let's first of all fix this. Now please, you open every lock. All right, so here is CH2. We can break this down and we'll put CH2, CH3. So remember, formally, what were we having here? C2H5. So I opened it and I got this. Now this is still the same thing. Two carbons, 2 plus 3, 5. So two carbons, 2 plus 3, 5. So it's the same thing here. So open this guy. So now by the time you open this guy, now you cannot properly get your longest carbon. So now let's count. 1, 2, 3. This cannot give you the longest. 1, 2, 3, 4. Cannot give you the longest. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6. No. So it's either you say 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So definitely our longest continuous carbon is what? Carbon chain is 8. And this 8, which alkane has 8 carbons, it is what? Octane. All right. So octane has 8 carbons. So we have this guy here, octane. So our parent chain is literally what? Octane. Okay, so our parent chain is what? Octane. So because octane is the alkane with what? 8 carbons. So this is what we have. Now, since we have identified this, remember I told you any group that is not part of the parent chain is considered as what? A substituent. A group not part of the parent chain is considered as what? A substituent. So we have substituent, substituent, substituent. Now this is a methyl group. So we have 2 methyl group and then we have what? 1 ethyl substituent. So now how do we name this? Now which direction that when we are numbering from that direction, we will have the least possible number on the first substituent or the first locant, or you say substituent. All right, now if you look at this, if we start with 1 from here, 1, 2, 3, 4. So our first substituent will be on what? Carbon 4. If we start from here, 1, 2, our first substituent will be on what? Carbon 2. So between 4 and 2, which one is smaller? Because we are using the smallest, the smaller number. So which one is smaller? is what? 2. So we start our numbering from this direction. So number 1, 2, 3, 4, 5, 6, 7, and then what? 8. So we have 2 methyl groups in carbon 2 and 3. So we have 2 dimethyl. Why am I using di? Because we have 2. Di is for what? 2, tri, 3, tetra, 4. Okay, so di is 2, tri is 3, 4 is tetra, or you say tetra is 4. So that is what you do. All right, so we have this guy. Then we now have our ethyl on what? Carbon 5. So we now have what? 5 ethyl. Now let us combine all of these substituents together. Now remember, ethyl, E comes before what? M, methyl. E in alphabetical orders, we have A, B, C, D, E, F, G, H, I, J, K, L, M. So E comes before what? M. So in order for us to properly name this compound, we will now name this compound. This compound here will now be named as what now? We now have what? 5 ethyl, 2 dimethyl octane. So include the parent chain. So this is the Iupac name of the compound. 5 ethyl, 2 dimethyl octane. That is the name of the compound. Now let's go to this other guy. We have CH3, CH2, CH, Br. So first thing first, open the structure. Anyway, you see kind of compactness, all right? Try to open it. So this is C2H5. So we have it as CH2, CH3. So now let us find what? The parent chain. Please, you must make sure you get this parent chain right. If you don't get the parent chain right, all right, which is the longest continuous carbon, if you don't get it right, you fade everything. That is it. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we follow this pattern, we'll get 9. If we follow this pattern, we'll get 9. If we follow 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So any direction, if you take it like this, we get 9. Take it like this, we get 9. Take it like this, we get 9. So please take note that the parent chain, please note, your parent chain does not have to always be horizontal. The parent chain does not have to always be what? Horizontal. It does not have to always be straight in a linear pattern. There is no rule that says that it must always be straight in a linear pattern. All right, it can take any direction. All that matters is that you make sure that the carbons are linked directly to each other. You see from here now, this guy is directly linked to what? This one's here. This guy is directly linked to this one's here, and this one is directly connected to this. This one is also directly connected to this. All right, so you can see it. So I'll decide to take this pattern. So these are parent chain. So when we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So our parent chain is 9. Which alkane has 9 carbon atoms? The answer is what? None. So those groups not part of the parent chain, they are considered as what? Substituent. So this is substituent, this is substituent, and what? This is a substituent. So now, which numbering direction will give us the least possible number, or which numbering direction do you have the first substituent at the smallest number possible? From here, 1, 2, 3, 4. So the first substituent is on carbon 4. From here, 1, 2. The first substituent is on what? Carbon 2. So here has the smallest number possible. So we use this numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that if you look through the chain, we have a methyl substituent CH3. I've told you guys how to get alkyl groups. I've explained how to get alkyl groups in my previous video. All right, alkyl and acyl group, the difference. Please go and watch that video. So this is a methyl group. This is what now ethyl group, and this is what a bromine atom known as bromo, because it is now a substituent. So we now use the name bromo. If it's chlorine, we use the substituent name chloro. So we have a 2-methyl. Our substituents are 2-methyl, 3-ethyl, and 6-bromo. So using the rule of alphabetical order. So now watch. So between M, E, and B, which one comes first? B, right? So the Iupac name of the compound becomes 6-bromo. Between M and E, which one comes first? E, right? So it now be what? 3-ethyl, then 2-methyl nonane. So this is the name of this compound. All right, I hope it is clear. Please, if it's not clear, please draw a comment below. All right, now let's do one more example to show you how a condensed structure can look like, why you always need to open the structure. So let's look at that. So look at this video. Look at this compound now. We have this CH3. All right, so we have this compound, and I asked you name this compound. Now this guy here, you have 3 methyl group attached to this guy. All right, so first of all, open this. So you now have what? CH3, and then what is CH3, then CH2, CH2, don't forget CH3, and then we have what? CH. Now I told you that your parent chain does not have to be horizontal or linear. There is no rule that says it must be linear. So just look for the carbon to carbon that directly connects each other, and then which carbon chain of that direct connection is longer. All right, so if you say 1 2 3 4 5, you'll be taking 5 as separation because you want to go with what? Linear or horizontal, but that's wrong. Now let's count. 1 2 3 4. This one is okay, but it's not the longest. 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. 1 2 3 4 5 6. So we can go anyways, but let's pick this pattern. Let's just use something like this. So any group not part of the chain is considered as what? A substituent. So substituent. All right, so 1 2 3 4 5 6. Which alkane has 6 carbon atoms? Hexane. So our parent chain is what? Hexane. All right, so now numbering. Now look the direction. All right, the direction where you have the direction that will give you the least possible number to the first substituent. All right, so the first substituent from here, if you start 1 2 3, is on carbon 3. The first substituent on this side, if you start from here, so it's 1 2. We have 2. So we are using this number 1 2 3 4 5 6. So it means that we have 2 methyl group in carbon 2 and then we have one methyl group in what? Carbon 4. So the name of this becomes what? 2 2, because you have two methyl groups in carbon 2, so 2 2. Then you also have another methyl group, so they are together. They are what? Together. Are you getting it now? So since they are together, they are, why did I say they are together? Because this is a methyl group, this is a methyl group, this is a methyl group. So the three of them, they are what? Methyl groups. So just combine all of them together because they are of the same kind. All right. So they are of the same kind. So 1 2 3, methyl methyl methyl. So you are not using any alphabet here. So 2 2 4, because this methyl group is on carbon 4. So 2 2 2 2 4. All right. Try methyl 224 trimethyl hexane. All right. So this is the name of the compound, 224 trimethyl hexane. Thank you very much for watching this video lesson. Now we're in the series of Iupac nomenclature. So I'll be dropping subsequent videos on how we can name alkenes, alkynes, and even some other homologous series. All right, how you can name members of that series. Thank you very much for watching. Please do it to like, share, and subscribe, and I'll see you in the next episode.